Hello everyone and welcome to Effortless Mastery. Today we'll be learning on chemistry of lipids. Very interesting topic. Of course, this is the first video we have for the year 2026. Very interesting topic that has given a lot of students concern where they read and they struggle with lipids. For you watching the video, you might have even had concerns or problems with it in the past. But of course, like I said, it was in the past. Because at the end of this video, you will be a master in this particular topic called chemistry of lipids. Now, what should we know about lipids? I had to bring out the key core things I want to discuss. The first thing is, before we jump into a topic, we have to know what are lipids. What are lipids? Lipids are broad groups. I use three words here to define lipids. Lipids are a heterogeneous group of organic compounds. So it is a vast group of organic compounds, heterogeneous, vast group of organic compounds who have a particular characteristic. One, they are insoluble in water. So lipids are insoluble in water. So solubility, they are insoluble in water, but rather they are soluble in non-polar solvents. Organic solvents that we have, they are soluble in organic solvents. So you realize that a lipid, when put inside water, an example of a lipid which would know oil, when you put inside water, it does not mix, it is not soluble. But if it is in another lipid or any other organic solvent, it will now be soluble. Then lastly, one core thing we see in lipids is that they are either actually related to fatty acids or potentially related. So there is a relationship between anything you label a lipid and fatty acid. It could be that in their structure, you have fatty acid in it. That's why they are called lipids. It could be that they could react with fatty acids. But along the way, they are connected to fatty acids. So three things we must know whenever we mention lipids. One, they are heterogeneous groups of organic compounds who are insoluble in water, soluble in organic solvents, and then related either directly or potentially to fatty acids. Now, what are the biomedical importance of lipids? What are the functions of lipids? Now, lipid is a source of energy. Of course, we know that the preferred source of energy for man is carbohydrates. So we have major classes of food: carbohydrates, lipids, and proteins. Amongst them, the one we really use for energy is carbohydrates. But funny enough, if I pick 1 gram of a lipid and pick 1 gram of carbohydrates and I use them for energy, the person that will give me more energy is lipids. So lipid gives you more energy. I think around 9 kilocalories of energy for every 1 gram of lipid compared with carbohydrate, which is way lower. So, but then, of course, if you eat food, carbohydrate is preferred source of energy. But then, and I think the reason for that is really on heat production. So please, we are done. So that's the first function, energy source. Second function for lipids, chemistry of biomedical function of lipids is structure. Lipids are very important in the structure of the body. So most cell membrane, if you look at the cell membranes, even when you look at cell membranes, within the structure of cell membrane, you see phospholipids, you would see cholesterol. I think one of my videos I did earlier included that, where you would see when we're talking about the structure of the cell membrane, I clearly told you that two components. There was a lipid component, which was phospholipid, cholesterol, glycolipids. So you see that lipids are important in structure. Number 3 is storage. So unlike glucose, which is stored as glycogen, and there is a limit to the amount of glucose you can store. Relatively, in the human body, there is really no limit to the lipid storage. That's why someone could eat, you keep growing, like you keep depositing fat and fat and fat, so that will keep happening. So there is little to no limit to how much you can store fat, but fat is a very important way of storage, so that even when we eat food, even though it was carbohydrate food you keep taking every day, ultimately your body will convert it to fat so that it can be stored. So that's for that. Then insulation and protection. Fats too, lipids play this role in insulation and protection. Oh, funny how I'm interchanging fat and lipids. I'll tell you as we go on. But yes, I am. Lipids is like the better name to use for it. Now, insulation and protection. Insulation, of course, that's you are preventing heat loss. Protection, just having fat around some organs protects those organs. So they form like parts around organs. Now, vitamins. Yes, fats are important in the production of these vitamins. Of course, you know vitamin A, D, E, and K are fat-soluble vitamins. Vitamin A, D, E, and K, lipid-soluble vitamins. So all of them are connected to lipids. Then, yes, lipids can also be used to form hormones. So a derived lipid like cholesterol can be used to form steroid hormones. So that is the function. Now, very quickly, what are the classification of lipids? Lipids are classified into three major classes. Lipids, simple lipids, compound lipids, and derived lipids. Who are simple lipids? Simple lipids are lipids that have fatty acids, that is in their constituent. When you look at their structure, all you would see is fatty acid and alcohol only. So when you look at the structure of simple lipids, all you would see is fatty acids and alcohol. I try to show the structure of, this is what in organic chemistry, this is how fatty acids look like. They are carboxylic acids. So this is how they look like. Now this is the general formula for alcohol. This was the general formula for carboxylic acids, which fatty acid is one of them. So when these guys, whenever you look at a structure, and in that structure you have carboxylic acid and alcohol only, that structure is a simple lipid. Compound lipids is when you have carboxylic acid. In this case, let me put it for you to see it. So fatty acid plus alcohol only is simple lipids. When you have fatty acids plus alcohol plus any other additional group, so fatty acid, alcohol, and any other additional group, that is called compound. Whereas derived lipids are lipids we get from the hydrolysis of the lipid. So what we have from hydrolysis of simple and compound lipids is called derived. So for example, if I hydrolyze a simple lipid, what it will give me will be fatty acid and alcohol. So those will be derived. So fatty acids and alcohol are derived lipids. Then similarly, if I was to hydrolyze any compound lipid, I'll have fatty acid, alcohol, and any of the additional compounds. So those are what we call derived lipids. Now, very quickly, simple lipids, I said they are, who do we have here? These are people that have fatty acids and alcohol only. Now, the two examples of simple lipids we have is neutral fats, or what most people just call fat and oil. Neutral fats. Then number two is wax. So neutral fat and wax. Now, what is neutral fat, or what we call fat and oil? Of course, fat, like I said earlier, fat, when I use the word fat, it is not as encompassing as lipids. So the better word to use is lipids. Now, neutral fats are also called triglycerides. They are also called triacyl glycerol. Let's come back to this picture. This was carboxylic acid, in this case fatty acid. This is alcohol. Now, the alcohol that has this guy here, which is these three carbons, that is propane, having three OH groups. Propane 1, 2, 3 triol is also called glycerol. So glycerol is propane 1, 2, 3 triol. Now, when you have glycerol together with 3 fatty acids, glycerol esterified to 3 fatty acids, this structure you have is called triacyl glycerol. 3. Acyl. Acyl is a fatty acid that has lost OH, or an acid, a carboxylic acid that has lost OH. Glycerol. So triacyl glycerol. You can also call it triglycerides. You can also call it neutral fats. So what do you see in this structure? You observe that to have a neutral fat, you need 3 fatty acids and then you need 1 glycerol. So glycerol and 3 fatty acids, that's what we have in neutral fat. It's important to know that fats will be solid at room temperature. So when you have fat, you bring out something, it's solid at room temperature, that is fat. But oil is liquid at room temperature. So you pick the vegetable oil we have in our homes. Those are oil. And one thing is, you can agree with me that when it is at room temperature, it should be liquid. It should be liquid. But then if you think of things like fat from meat, you realize that in those ones, they are solid at room temperature. So that's just by the way. So here, what are we to note? Neutral fat are also called triacyl glycerol, triglycerides. 3 fatty acids with a glycerol. That's what makes it up. Now, waxes. So waxes is when you have 1 fatty acid reacting with a monohydrate alcohol. You know what we mean by monohydrate? Monohydrate means that alcohol has only one OH. If you observe here, glycerol is a trihydrate alcohol. It has 3. So if I have an alcohol that just has one OH, and then I react it with one fatty acid, what I have, that ester I have is actually called wax. Wax. So that is simple lipids. What is the key thing we see here? All they have in their structure is fatty acids and alcohol. So for neutral fats, the alcohol is glycerol. For waxes, the alcohol is a monohydrate alcohol. Now, number 2, for neutral fats, you needed 3 fatty acids, but for waxes, you needed how many fatty acids? Just 1. Now, I'll come back to compound lipids. For compound lipids, people will have under here, based on the additional group, you give it name. So imagine the additional group here was phosphates. The name of this compound will now be called phospholipids. If the additional group here was carbohydrates, it will be called glycolipids. If it was a protein, it will be called lipoprotein. And funny enough, if it was sulfur, it will now be called sulfolipids. So that is just how we name them. So those are compound lipids. Derived fatty acids, alcohol. So quickly, let's talk about derived lipids. In this case, fatty acids. So fatty acids will just be an organic compound that has a carboxylic group in it now. So it's going to be having an hydrocarbon. So when you look at the chain, like I did here, you have an alkyl group, which is just an hydrocarbon. At the end, that's where you have your carboxylic acid group. So now, there are 2 types of fatty acids, saturated and unsaturated. It follows the same principle of chemistry. Saturation means that everywhere is filled. So that means there is no double bond or triple bond. So everything you have in that compound will be single bond, apart from the functional group. So the aliphatic chain, that is this hydrocarbon chain, the alkyl group, all you have there will be, everywhere will be filled, no double bond. That's saturated. Unsaturated is when there is double bond. So we have some examples of saturated. An example of saturated will be palmitic acid. Palmitic acid is actually a fatty acid that has 16 carbons. Palmitic acid, palmitic acid is very common. Could also have stearic acid. Stearic has about 18 carbons. 18 carbons. So these are saturated, and I said saturation means no double bond. Saturation simply means no double bond. When you come to unsaturated fatty acids have a double bond. Now, depending on the number of double bond, they can either be mono or poly. Mono unsaturated means you have just one double bond. Polyunsaturated means you have what? More than one double bond. An example of mono unsaturated is someone we call oleic acid. Oleic acid. Oleic. For example of polyunsaturated, we have linoleic. That just add lin before this. Linoleic. Other ones we have this other one called linolenic. Linolenic. And we have arachidonic acid. All of them are polyunsaturated. Please remember I said oleic acid is where mono unsaturated. And oleic acid actually has 18 carbons. Yes, it has 18 carbons. And within the structure, this is what oleic acid looks like. C18. There's a double bond, only one double bond, and that double bond is at position 9. Yes. So this is something you are going to be seeing. This is how we name fatty acids. Carbon 18 means that the length of the carbon chain is 18 carbons. Triangle here tells you about double bond. So this is how we name unsaturated. The triangle tells you double bond. So when you see triangle 1, it means one double bond. So this compound here called oleic acid has 18 carbon atoms, one double bond, and where is the position of that double bond? That is number 9, which is position 9. So position 9 will be between carbon 9 and carbon 10. So that is that for that. Linoleic, which is polyunsaturated, you see something like C18, triangle 2, 9, 12. So 9, 12. So this is how it is. Observe something. C18 means how many carbons? 18 carbons. Triangle 2 means how many? 2 double bonds. And then, where are the double bonds? Position 9 and position 12. Someone like linolenic is now C18, triangle 2, 9, 12, 15. So what does that? Sorry, triangle 3. What does that tell you? That for linolenic, it is 18 carbon, 3 double bonds, Those double bonds are in which position? 9, 12, and 15. A cheat code is that you just add 3 to the numbers. You are correct. Then lastly is now the other guy I mentioned, arachidonic acid. Also an example of polyunsaturated. Arachidonic will be carbon 20. It has 20 carbons. The number of double bonds here is 4. But the double bond is not following this pattern. They all start from 5. 5 plus 3, 8. 5, 8, 11, 14. 5, 8, 11, 14. Just add 3. You have your trick, and that is that for that. So please, for types of fatty acid, what do we have? Saturated, which there is no double bond. Example, palmitic stearic acid. For unsaturated, there is double bond. And when there is double bond, the question is now how many of them? If it is one, that will be monounsaturated. Example, oleic acid, who has the double bond at position 9. Then polyunsaturated, which is 3 examples: linoleic, linolenic, and arachidonic. Please note, all these polyunsaturated I've mentioned, all of them are essential fatty acids. We go back to my topic on amino acids. I told you essential are things the body cannot produce. So you need them in your diet. You need them in your diet, especially linoleic and linolenic. We are told that to some extent, arachidonic acid can be produced in the body, but very in minimal quantity. But just if you ask as a question, all 3 are essential fatty acids. Now, that covers fatty acids. Alcohol, of course, you know what alcohol is. We are not doing chemistry, so I can't go into the details. So you just know alcohol is someone that has an hydroxyl group. And when you look at it, like I had mentioned during the course of my talk, there's glycerol. You could also have normal monohydrate alcohols. You can even have some funny alcohols. There's one alcohol we call sphingosine, which even is an amino alcohol. But let's not go through all those traits. Now, next up is now phospholipids. It's now us. I want to dwell on the compound lipids. Phospholipids, glycolipids, lipoproteins. Now, for my phospholipids, what should be known? Phospholipids are lipids that have, in addition to fatty acid and alcohol, what they will now have will be phosphate group and nitrogenous base. Not all of them shall, but most of them have nitrogenous base. So you would realize that in their structure, see, go back to your triacyl glycerol, if you observe how it was. The glycerol base, one of the fatty acids is replaced with the phosphates. So because it is replaced with the phosphate, we call it phospholipids. But like I added a NB, there is also to some extent an addition of a nitrogenous base. That is what we call phospholipids. What are the classification of phospholipids? Some books will tell you 2 types, some will tell you 3, and I'll give you the reason for that. The 2 major types is glycerophospholipids. The second one is sphingophospholipid. What does glycerophospholipid mean? Glycero, from the name, the alcohol here is glycerol. That's why it's called glycerophospholipids. For the second class, the alcohol there is sphingosine. I tell you, glycerol is this person here. 1, 2, 3. Propane, 1, 2, 3, triol. Sphingosine is just an amino alcohol. So that is just that for that. I think that's what I would like you to take note of. Now, for my glycerol, an example of the sphingosine is, that sphingophospholipid is sphingomyelin. Of course, you know sphingomyelin, that will be in myelin sheets. Sphingomyelin. Now, but my glycerophospholipids has several examples, which I would like to list. Lecithin, Lecithin. Lecithin is also called phosphatidylcholine. Why is it called phosphatidylcholine? Because in its structure, come back here. You remember this is my structure. This was my phosphate group. The nitrogenous base, this same structure, but the nitrogenous base here is choline. So because the nitrogenous base is choline, the structure is called phosphatidylcholine or lecithin. Similarly too, you see this guy we call phosphatidic acid. Phosphatidic acid does not have a nitrogenous base. So all of these people will have a nitrogenous base. Yes, most of them will have it. Phosphatidic acid does not have it. So it is just this structure, no nitrogenous base. That is phosphatidic acid. When the nitrogenous base is choline, it's called lecithin. When it is ethanolamine, it is called cephalin. Then we could also have the nitrogenous base even being serine. You know, serine is an amino acid. Yes, it could even be serine. And if it is serine, the structure is called phosphatidylserine. Of course, lecithin is the most abundant among all of these. It is the most abundant. And then it is important in, there's a particular type of lecithin. You see it in cell membrane. It's also the most abundant in cell membrane. That's phosphatidylcholine. It is important in particular type of, is it palmitoyl, dipalmitoyl lecithin. That particular one, DPL for short, is important in formation of lung surfactants. In embryology, we are taught that for the lungs to expand or to stay without collapsing during development, there's something that prevents collapse of lungs, and that is called surfactants. It was produced in embryonic life. During that time, please, what is important for its formation is DPL, dipalmitoyl lecithin. So lecithin is very important. And whenever surfactant is not available, the child is born with a disease called respiratory distress syndrome, RDS. Now, so please, that is just that for we have other examples, plasma, logens, cardiolipins. All of these are just examples of glycerophospholipids. Observe, I told you a plus or minus the last type, which is phosphoinositide. I can just call it phosphatidylinositol. Phosphatidylinositol, the trick here is it has another alcohol. Like what would have been, so the books that mention it as 3 classes, it is this same structure, but instead of nitrogenous base, you have an alcohol here, and that alcohol is called inositol. So some people regard it as a separate class in that it is not following the pattern of having a nitrogenous base like glycerophospholipid has. Here, glycerophospholipid, the only alcohol you have is glycerol. But in phosphoinositol, in addition to glycerol, there is another alcohol. So not a nitrogenous base, and that alcohol is inositol. So based on what you are taught, or the school, whichever book you're reading, you could mention this as a 3rd type or a 3rd class, or it could be as part of glycerophospholipids. Now, for my sphingophospholipid, I mentioned that the example is sphingomyelin. Now, we have other things apart from phospholipids, other compound lipids, glycolipids, which we have cerebrosides and gangliosides. Now, what is important about glycolipids? It is carbohydrate. There is no phosphate here. There is no nitrogenous base. Please, you can write it down. No phosphates, no nitrogenous base. So for my glycolipids, we have, and then the alcohol for these people is sphingosine. The alcohol we find in both of them is sphingosine. So I have cerebrosides and gangliosides. Cerebrosides, the only difference between them is that the carbohydrate in cerebroside is just a simple carbohydrate. And it could be glucose, it could be galactose. So if it was glucose, you now be calling it glucocerebroside. If it was galactose, you call it what? You get it, galactocerebroside. But gangliosides are funny in that the carbohydrate here is a complex carbohydrate. So they might have the glucose, they will have the glucose or galactose, but they will still have some things like neuraminic acid, NANA, one we call NANA. So it's just complex, whereas this other one is what? Simple, cerebrosides, gangliosides. We have different kinds of gangliosides. We have GM1, GM2, GM3, and even GM4. So that is that for that. So quickly, the clinical correlates really associated with the chemistry of lipids. These are really, for some books, they will just write them as lipid storage disease, when you have accumulation of different lipids. So Niemann-Pick's, Niemann-Pick's. Niemann-Pick's disease is when there's accumulation of sphingomyelin. Accumulation of sphingomyelin, it is called Niemann-Pick's. Of course, it's going to be a deficiency of an enzyme. Now, Gaucher's disease is due to the accumulation of a type of cerebroside called glucocerebroside. Then Graves' disease, that is this other one, KRABBES, is the accumulation of galactocerebroside. Whereas glucocerebroside is what? Gaucher's disease. Tay-Sachs, which is TAY, Sachs disease, is the accumulation of a particular type of ganglioside, which is ganglioside GM2. So that is all for the chemistry of lipids. So we have known what lipids are, being guys that are soluble in other lipids and organic solvent, but insoluble in water, related directly or indirectly to what? Fatty acids. We've looked at the functions. We have seen that under classification, it can be simple, compound, or derived. Simple will have only fatty acid and alcohol only, whereas compounds will have fatty acid, alcohol, and an additional compound or additional group. Then for derived, this is what we get from hydrolysis of simple and compound. Then types of fatty acid is saturated and unsaturated. We mentioned which one is essential. You should take note of all of those. Then we now go to the phospholipids. We mentioned that there are different classes. Phospholipids will be having phosphates and nitrogenous base, not all. So there are different classes. It could be glycerophospholipids, sphingophospholipid, or even phosphatidylinositol, which is phosphoinositide. But some books will add phosphoinositide as an example of glycerophospholipids. Then the clinical column name picks accumulation of single myelin, Gaucher's disease, and the accumulation of glucocerebroside, Tay-Sachs as the accumulation of ganglioside type 2, and then Graves' disease accumulation of galactocerebroside. Thank you so much for joining us. I do believe that this was as simple as possible. If you have any question, feel very free to type it out in the comment section. And if you have a topic you want us to treat, please mention it in the comment section too. I think this topic was even requested. That is why it was done. So you can also request for a topic and it will be explained. Please ensure you like this channel, ensure you subscribe to the channel, share these videos to as many people as possible. You know this video is helpful to you and you know it can help others. If you have to watch it again to ensure you understand everything, please do so. Thank you so much for joining us today. Until next time.